According to a recent study inspired by ice giants like Neptune and Uranus, ordinary plastic can now be converted by lasers into microscopic diamonds. Researchers have demonstrated the existence of an unusual new type of water by using incredibly powerful lasers to shatter inexpensive plastics into tiny nanodiamonds. Stay tuned to our channel, Incredible Tech, to know more about this spectacular process of turning plastic into diamonds. While there are plenty of sources of carbon for scientists to use, they realized in the 1970s that there is a serious garbage issue on Earth due to the substantial amount of trash produced by disposable items like plates, lunchboxes, and glass. Polystyrene, sometimes known as styrofoam, is the material used to make these disposable cups, lunchboxes, and plates. Scientists have always worked to reduce this garbage, which implies that it should be recycled or, even better, turned into diamonds, since it is made of carbon and is bad for the environment. Although nanodiamonds have now been created, there is a problem with the high conversion cost, which is something we do not want. Additionally, this method creates nanodiamonds, whereas larger diamonds are expected. So, in 2022, scientists reportedly achieved excellent findings after experimenting with a new substance. PET, or PET as it is most often known, stands for polyethylene terephthalate. You must be familiar with PET bottles. Styrofoam was weak though, which is why we have now chosen PET. It's crucial to note that oxygen is a factor. Scientists discovered that oxygen, hydrogen, and carbon are present in those frozen giants' atmosphere, and they concluded that oxygen can improve this process and allow us to produce microdiamonds of a few micrograms, rather than nanodiamonds. So the point is that the scientists used PET in place of styrofoam and achieved excellent results. We can now produce a few micrograms of diamond because the addition of oxygen significantly improved the conversion. Scientists also experimented with an additional method known as X-ray diffraction, which Bragg's law explains. Hydrocarbons are known to be beaten into the crystalline bling that they engaged covet under high pressures and temperatures thousands of kilometers beneath the surface of a planet. The universe's method of creating diamonds is a little bit more intriguing on distant Neptune and Uranus. The presence of oxygen increases the likelihood of diamond formation, allowing them to form and grow at a wider range of conditions and throughout more planets, according to researchers from the Department of Energy's SLAC National Accelerator Laboratory and other colleagues, who investigated this process in a new material that more closely resembles the chemical composition of Neptune and Uranus. Diamonds that are only a few nanometers across, or billionths of a meter, are called nanodiamonds. They have both current and future uses, including converting carbon dioxide into other gases and delivering medications to the body. Planetary scientists have long held the suspicion that diamonds develop deep within the icy innards of ice giants like Neptune and Uranus. These diamonds would rain through the innards of these frozen worlds if they did materialize. First, we need carbon to make diamonds. Second, a great deal of temperature. And third, a great deal of pressure. Krauss and his colleagues bombarded polystyrene, which includes the same elements of carbon and hydrogen found in Neptune and Uranus, with the LINAC coherent light source, a powerful X-ray laser at the SLAC National Accelerator Laboratory in California, in their initial attempt to create nanodiamonds from it. In a technique that heated the polystyrene to 5,000 Kelvin, or roughly 8,540 degrees Fahrenheit, in a matter of seconds and compressed it by 150 gigapascals, researchers were able to replicate temperatures that are found around 6,000 miles inside the interior of the cold planets. This resulted in just billionths of a second pressures that were millions of times greater than those of the Earth's atmosphere. As a result of the plastic being shocked by this bone-crushing pressure, the carbon atoms changed their arrangement to form a crystalline structure with hydrogen and oxygen drizzling across this lattice. Since 1970, diamonds may have literally been raining down from planet interiors, claim experts. According to Krauss, we could view the sample's interior and produce movies of the chemical events taking place there using a strong X-ray laser. Within the limits of our studies, which lasted only a few nanoseconds, we observed the extremely effective production of nanodiamonds within the compacted polymers. According to the new research, this kind of diamond creation may occur more frequently than previously thought, increasing the possibility that ice giants may have extensive diamond layers surrounding their solid cores. The scientists observed the atoms' reorganization into tiny diamond areas using a technique called X-ray diffraction, and they also gauged their size and growth rate. However, they discovered that the nanodiamonds were able to develop at lower pressures and temperatures than previously noted when oxygen was included in the material. The oxygen speeds up the carbon and hydrogen splitting and encourages the creation of nanodiamonds. The experiment also strongly implies that a strange water condition known as superionic water ice forms at the high temperatures and pressures present in the interiors of such frozen worlds. In this particular type of water, protons can pass through an oxygen atom lattice. According to Krauss, if superionic water is present on ice giants like Uranus and Neptune, the flow of protons through this unusual matter may contribute to creating the planet's strange magnetic fields. Previous simulations predicted that any superionic water that formed in planetary interiors would be incredibly unstable due to the presence of carbon atoms. But according to Krauss's research, carbon and water are demixing and unintentional separation of the constituents in a combination via diamond formation. Thus, it is possible for isolated water to exist inside planets, which increases the likelihood that superionic water would emerge. Considering that only hydrogen and carbon are present in polystyrene, it was employed to replicate the structure of methane. The scientists used 2 fast laser blasts to create the microscopic bling, but they later discovered oxygen, a crucial chemical component, was absent. They then went to PET because it was a nice balance of oxygen, hydrogen, and other elements, giving it a more accurate chemical representation of the ice giants than polystyrene. Scientists saw carbon atoms being integrated into tiny diamond formations up to a few nanometers wide as a result of the powerful X-ray shockwave effects on the material. According to researchers, the diamonds within Neptune and Uranus would grow to reach millions of carats in weight, much greater than those created in these trials. The leftover hydrogen atoms can then float inside of the regular lattice structure that the oxygen atoms have formed, where they can conduct electricity when charged. In addition to their current usage in abrasives and polishing agents, nanodiamonds may also find utility in developing quantum sensors and speeding up renewable energy conversion processes like carbon dioxide splitting. According to SLAC researcher and collaborator Benjamin Ofori-Okai, the present method for creating nanodiamonds entails taking a large quantity of carbon or diamond and detonating it using explosives. This results in difficult-to-regulate nanodiamonds of different sizes and shapes. This experiment demonstrates how the same species can react differently when exposed to high temperatures and pressure. An easier and cleaner way to create nanodiamonds might be through laser manufacturing. We can alter how rapidly they form and, consequently, how big they grow if we can develop techniques to alter some aspects of reactivity. Deep under the Earth's crusts, almost 3 billion years ago, under extreme heat and pressure, diamonds found naturally were created. Diamonds are created when carbon atoms crystallize under these circumstances. Look, carbon exists on Earth in a variety of forms, and diamond is an allotrope of carbon. For instance, it can appear in the form of graphite, coal, or in a third case, carbon. A PET film would receive 10 flashes per second from a powerful laser, with the beam's illumination occurring every 10th of a second. Nanodiamonds would eject from the film and drop in a water-filled collection tank. There, they slowed down, making it possible for scientists to filter and successfully harvest them. Krauss emphasizes that the nanodiamonds might be sized specifically or even doped with other elements. They now have a laboratory tool that can accurately control the formation of the diamonds thanks to the X-ray laser. We can now turn PET bottles and other PET garbage into diamonds instead of using the previous method. This method allows us to swiftly and easily obtain small diamonds. It's excellent news for the environment that we can recycle PET bottles and turn the vast amount of garbage they produce into diamonds. You may receive offers in the future to turn your PET waste into diamonds, for example. As a result, it will be a terrific method that will cut down on waste and serve as a very good alternative to recycling. That's all for today. If you liked our video, give us a thumbs up, and don't forget to subscribe to our channel. Hit the bell icon to get notifications for upcoming posts.